All right, lesson 13, I can restate a ratio in terms of its value. I can use the value of the ratio to problem solve by writing and solving equations. So today we're going to be looking back at ratios and how, from a basic perspective, but noticing relationships to form equations. So we're going to have some equation writing going on, kind of stepping a little bit into some algebra concepts. So let's get started. Okay, so I'm going to be using this model of a three yellow cubes here to one red cube to demonstrate this problem. George is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. I can see that modeled here, 1 gallon of red, 3 gallons of yellow. Based on this ratio, which of the following statements are true? So the first one says 3/4 of a 4-gallon mix would be yellow paint. So if this mix of orange paint is 4 gallons, 1, 2, 3, 4, yeah, I see that 3 of the fourths are yellow. So this one's true. The second one says every gallon of yellow paint requires 1/3 gallon of red paint. Well, if we only had 1 gallon of the yellow, that's only 1/3 of the amount of yellow that we need. So I would only need to use 1/3 of the red for just 1/3 of yellow mixture. So this is true as well. Every 1 gallon of red paint requires 3 gallons of yellow paint. Yes, this is true. 1 gallon red, 3 gallons yellow. There is 1 gallon of red paint in a 4-gallon mix of orange paint. Yes, I see 1 gallon of red in the total 4-gallon mix of orange, so this is true. There are 2 gallons of yellow paint in an 8-gallon mix of orange paint. So if we have 8 gallons all together now, that means that we would have another one of these guys. So I'm just gonna kind of model that here. So another 3 parts yellow to 1 part red. Okay, so that makes our 8-gallon mix of orange paint, which is another one of these here. So are there 2 gallons of yellow? If each yellow represents 1 gallon, are there only 2 gallons of yellow? Well, no, I see 2 gallons of red, but I see 6 gallons of yellow. So I'm gonna say false. There would be 6 gallons of yellow. I'm sorry, yeah, there would be 6 gallons of yellow. This next part says use the space below to determine if each statement is true or false. So again, referring back to my little model here, when I'm remembering how many parts red paint to how many parts yellow paint, it was 1 part red to the 3 parts yellow, because 3 equals 1 times 3, that's a relationship. So like we talked about when there were 2 red, now there would be 6 yellow, because 6 equals 2 times 3. Now if I added another orange mixture here, I would have 3 parts red to 9 parts yellow, because 9 equals 3 times 3. 4 parts red would be 12 parts yellow, because 12 equals 4 times 3. And 5 parts red to 15 parts yellow, because 15 equals 5 times 3. One thing we're noticing that I'm writing about these relationships is when we first started talking about ratio tables back a couple of lessons ago, one thing we noticed was the relationship, or what the constant was to get the numbers in the ratio, how they corresponded. So for example, I can notice here that if I take 1 and I'm multiplying by 3, I get 3. So that would be the same all the way down. Okay, every time in each row, I'm multiplying the first number times 3 to get the second number. So that's why when we write out the relationship, we are always writing times 3, 5 times 3, 4 times 3, 3 times 3. The relationship means how can I get this number? What is the constant to give me the next number? So in this instance, those will always be matching. You'll always have this constant represented as the same number all across the different equations in this column of relationship. No matter how many gallons of red paint I have, I could figure out how many gallons of yellow paint I needed knowing that constant. For example, if I wanted to make orange paint to cover our school and we had 100 gallons of red paint, I could figure out how many gallons of yellow paint that I would need by multiplying 100 times 3, and I'd get 300. So I know I would need to go out to the store and buy 300 gallons of yellow paint. Connecting this information back to our content goal and what we know about values, again, if this ratio is a 1-to-3 ratio, the value of this is 1/3 or 1/3. So if I wanted to figure out the other way and I wanted to know how many red gallons of paint I needed, so say I wanted to paint the school and I knew that I had 300 gallons of yellow paint, I need to multiply that by 1/3 to find how many gallons of red paint, kind of going backwards. Multiplying by 3 is the same as multiplying by 3/1. So if I want to go the other way, I multiply by 1/3 the value to get the amount of red paint that I would need. Okay, for this next section, exercise 3, George now plans to mix red paint and blue paint to create purple paint. The color of purple he has decided to make combines red paint and blue paint in the ratio 4:1. If George can only purchase paint in 1-gallon containers, construct a ratio table for all possible combinations for red and blue paint that will give George no more than 25 gallons of purple paint. So we want to make sure that the total is no more than 25 gallons. Okay, so as we're moving down the list here, one thing I want to point out is, and let me zoom in, on our table, it lists it blue and then red, so the ratio would be blue to red. But in the directions, they told us the ratio red to blue, 4:1. So if I just took that 4:1 and I put 4, 1, that is backwards because this is a red to blue ratio. So I want to make sure that my the red, which is 4, goes under the red column, okay? And the number of blue is 1. That needs to go under the blue column. So this is actually a 1-to-4 when we're talking about blue to red. So just be careful and make sure you keep the relationship consistent. And that will get us to our total. And we can see here 4 equals 1 times 4 because we are multiplying times 4. That's going to be our constant. So the relationship of all of these should have that times 4, times 4, times 4. Okay, now every time we add another gallon of blue paint, we have to add 4 more gallons of red paint, and that's why we're saying every the constant's always times 4. So now there'll be 8 gallons of red paint because 8 equals 2 times 4. Okay, if we add another gallon of blue paint, again that constant times 4 would give us 12 gallons of red paint because 12 equals 3 times 4. 4, 16 equals 4 times 4. and 5 to 20, because 20 equals 5 times 4. Oops, needed to zoom back out, sorry about that. Because 20 equals 5 times 4. Okay, now we're going to answer some questions about this data. First prompt says, write an equation that will let George calculate the amount of red paint he will need for any given amount of blue paint. So if we need to figure out how much red paint, well, we did that. And what we did was we multiplied however much blue paint times 4 to get the amount of red paint. So in our equation, we're just going to write, we could write blue times 4 equals red, but that doesn't look really like an algebraic equation. So we could use just letters to, instead of writing out those words, so we'll just use B for blue times 4 equals R for red. That's a simplified version of that equation. Looks more like a math equation that way. Now for the next one, we're kind of going in reverse. So it says, write an equation that will let George calculate the amount of blue paint he will need for any given amount of red paint. So let's take a look at an example here. So say we knew we had 8 gallons of red paint. We needed to know how many gallons of blue paint. Well, we could see that what we're doing here is we are dividing by 4 to get the amount of blue paint. However, if we're talking about a multiplication equation here, dividing by 4 is the same thing as multiplying by 1/4. So we're going to go ahead and write 1/4 times, and do you remember how we abbreviated red in the last one? We just wrote the letter R. So 1/4 of whatever this, the amount of red paint, that would give us the amount of blue paint that we needed. For example, 1/4 times 8, we would get 8/4, which reduces down to 2. So just to prove that this equation is true here, because if we're going from blue to red, we are multiplying by 4. If we are trying to figure out red to blue, we are dividing by 4 or multiplying by 1/4. The next one says, if George has 24 gallons of red paint, how much blue paint will he have to use? So we just talked about that, the relationship of finding the amount of blue paint in gallons if we know the amount of red paint. So we do know the amount of red paint. It's 24. Okay, and we just said in order to find the amount of blue paint, we are multiplying by 1/4. So we can do 24 times 1/4. I'm gonna get 24/4, which reduces to 6. So 6 gallons of blue paint. And the last one, if George has 24 gallons of blue paint, how much red paint will he need to use? So 24 gallons of blue paint, and I know that I need to multiply that by 4 to get the red paint, because we said blue times 4 is going to give us red. So 24 times 4, multiply that, and what do you get for the amount of red paint? Go ahead and pause the video, solve that. Let's check your answer. When I multiplied that, I got 96. So 96 gallons of red